Today's lesson is Introduction to Binomial Theorem. If your teacher has just taught you this topic and you are still confused, this is the lesson for you. This is the given binomial expansion formula. But first of all, what is binomial expansion? Binomial expansion is expanding two terms squared. So this one, no problem. Every one of you should be able to tell me that this is equals to a squared plus 2ab plus b squared. How about if I increase the power to 3? Some of you still can tell me that this is a cubed plus 3a squared b plus 3a b squared plus b cubed. But does any one of you can tell me what is the answer to this? Let's see, 37. If I ask for the first four term, there's no identity to it. It's quite tough. So there is this theorem. A theorem is a formula that is always true under a given condition. So your condition for this formula is n must be a positive integer. Now let's get used to this formula by applying it to this expansion. So first of all, we write all the bracket term first. Alright, that 4c0, then followed by 4c1, 4c2, 4c3, and the last one will be 4c4. You start with 0, you end up with the same power. Alright, 0, you slowly increase by 1. Now next, we fill in this term 2. So you always start off with 2 to the power of 4. 2 to the power n. Alright, but your n is 4. So it's 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Next is the b term. This is the a term, okay? Now b, you start with 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, and 3 to the power of 4. Now, you notice that a few things here. This is 4. How many terms are there? There are 5 terms. Because you start with 0, you end off with the nth term. Alright, so n is 4. So 0, 1, 2, 3, 4. Altogether 5 terms. So if you have n, you have n plus 1 term here. So n is 4, so this is 5 terms. The other thing you take note is, look at this. These two add up to 4. This one add up to 4. This one add up to 4. This one add up to 4. And this one add up to 4. Now, so you add all this up, will be equals to this answer. Okay? So what will you get for this? This one you will get 16. Now 4c0 is 1. Alright. Now a few things you need to take note. nc0 is always 1. You can press into your key into the calculator, you will find it's 1. But it's good to remember this. ncn is also 1. When these two numbers is the same, is 1. Now you press this in the calculator, this will give you 96, and this will give you 216, and this one will also give you 216, and this one will give you 81. You add all this up, you find that this is equals to 625. And you can verify by doing a 5 to the power of 4, you find that this is 625. So we have verified that the theorem is true for n equals to 4, and when A is 2 and B is 3. Now let's move on to another example. Now that you have learned the binomial theorem, let's get more familiar with it by doing this extension. 2x minus y to the power of 4. Let's do the NCR term first. So n is 4. So we start with 4 to the power of 4C0, followed by 4C1, followed by 4C2, followed by 4C3, followed by 4C4. Next, we will do the 2 to the power 2 times x term. So it will be 2x to the power of 4, 2x to the power of 3, 2x to the power of 2, 2x to the power of 1, and 2x to the power of 0. Next, we do the minus y term. So you have minus y to the power of 0, minus y to the power of 1, minus y squared, minus y cubed, minus y to the power of 4. Now it's to the power of 4, so there should be 5 terms. Alright, it's always the power plus 1 term. So if the power is 4, so you have 5 terms. Please take note, all these will add up to the power. 4 plus 0, 4. 3 plus 1, 4. 2 plus 2, 4. So on and so forth. Now let's look at this term. This term is positive. This term is negative. This term is positive. This term is negative. It's a positive number and a minus a number inside. When you expand, you always start off with positive, negative, positive, negative, positive, and then it's just alternate. So let us add all this up together. Okay, this will not be there. This is just to show you. Let me cross it out. Now you expand this term and you add all of this up. Now, so the first one you will get 16 x to the power 4 minus 32 x cubed y plus 24 x squared y squared minus 8 x y cubed plus y to the power of 4. So this is the final expansion. Now, let's move on to another example where we need to approximate 1.01 if we do this expansion to the power of 7. We are asked to find this approximation up to 4 decimal places. Now we can find this approximation using binomial theorem. Let's do this expansion, but bear in mind that what they want is only up to 4 decimal places. So same thing, we do the NCR term first. So 7C0, 7C1, 7C2, 7C3, 7C4. Maybe we just stop here for the time being. I will explain to you why. Now next, we do the 1 term. So it's 1 to the power of 7, 1 to the power of 6, 1 to the power of 5, 1 to the power of 4, 1 to the power of 3. Next, let's do the 0.01 term. So you have 0.01 to the power of 0, 0.01 to the power of 1, 0.01 squared, 0.01 cubed, 0.01 to the power of 4. Now what is all this term? Next, you can press the calculator for each and every one of them and you add all of them up. So this one you will get 1. This you get 0.07, followed by 0.0021, followed by 0.000035. Now this one you don't need to do anymore. Why? Now the question asks you to expand up to 4 decimal places. For this, we already reached the 6. So when they ask for 4, you must do up to 5, alright, or 6. Because you may need to round down or round up. You must see the 5th decimal place, alright. But the 5th decimal place depends on the 6th. So to be on the safe side, you expand up to the 6th decimal place should be good enough. Okay. Now, then you add all of them up, all of these up, and that should be your approximation. So you got 1.072135. Now 4 decimal place, so that will be approximately 1.0721. This is your final answer to this. But one thing to take note is that we are ignoring higher powers of 0.01. Now, why can we do that? Because when you raise 0.01 to a positive integer, you find that it becomes smaller and smaller because of the decimal place, alright? Because 0.01 is less than 1. So if you increase its power, like power of 2, power of 2, power of 3, you find that this number actually gets smaller and smaller. That's why we can use this to approximate it. Now if this is not 0.01, let's say if it's a number greater than 1, let's say this number is 2, you find that that won't be accurate. In today's lesson, you have learned how to use binomial theorem formula. In the next lesson, I will use what we have learned today to solve these 3 interesting sums. I'll be putting the URL link in the description below. For those who are interested, please click on it. And we hope to see you again. Have a nice day. Thank you.